Kia ora koutou, Morena, ko Yvette Wooten ahau. Good morning and welcome everyone. For those of you who weren't in the last session, my name is Yvette and I'm chairing the workflow session today. So we have an additional presentation and a lightning talk for this half of the workflow session. We will hopefully end promptly at 12:10, so we'll be sticking to the schedule as closely as possible. A reminder again, please post any questions you have for the presenters in the live Q&A, which can be clicking the Q&A button on the bottom of the screen. And should you have any technical difficulties, select the red live support button in the top right corner of your screen. If you leave, remember you can do this by clicking return to the timeline on the top. So our next speaker today is Adam Hyde from the Cocoa Foundation, who will be talking about building efficient workflows for the rapid review of time-sensitive research. So I'm going to hand over to Adam now.
Okay, hopefully you can hear me. I'll just, before I switch full screen, okay, let's go. Hi, my name is Adam Hyde. I want to talk about building efficient workflows for the rapid review of time-sensitive content. I'm flying a little bit blind, so I can't hear anybody at the moment, so let's see how we go. So just a little bit about me. I'm the Cocoa co-founder. I've done a lot of stuff in openness and publishing, and I work a lot with researchers and publishers, authors, etc., in scholarly communications, also other types of publishing, but really primary focus that I've had for the last 10 years or so has been scholarly publishing, after having designed a platform for Public Library of Science and then started the organization Cocoa. Just a little bit about Cocoa. Cocoa, we're a not-for-profit. We build publishing platforms, all open source, and just a little bit of an idea of the kind of communities that we work with. They're quite diverse, and we're really involved in building a lot of different types of platforms, from micro-publication platforms to content aggregation platforms, journal preprint platforms, book production platforms, etc. So you can always email me should you wish to at adam@cocoa.foundation, and yeah, I'm based in Raglan. If anybody's in Raglan, always happy to get a coffee. So I want to talk a little bit about it's not the same kind of workflows that we've been talking so far in this conference. This is more or less a human problem, human coordination problem. Workflow referring to, in this context, the coordination of people to process documents. And I'm just going to dive very quickly straight into it. Essentially, preprints, we all know, they've been around for a long time. They've been a very handy tool for researchers to basically circumvent slow journal publishing timelines and get the content out there faster. And they've sort of been around, but they've never really been a challenge to journals, and that's been a very political position that they've contained themselves within. They haven't wanted to be a threat to journals. So preprints exist so long as they don't hassle journals. It's been a sort of prehistory. But with COVID, there was enormous influx of preprints. Obviously, researchers were researching a lot of things and getting it out quickly. But we soon realized what a new kind of preprint utopia was like, and there was upsides and downsides. Upsides, preprints were taken more seriously. Downsides, essentially, researchers were drowned in data, and it's very hard to tell in that environment what is good and what is bad data. So the first kind of response to this has been various organizations emerged and managed community preprint reviews of COVID material. So these were very much ad hoc efforts that became more coordinated over time. It was obviously a sort of an emergency response. And their tool sets, because there's haven't been that many, if any, flexible preprint platforms, the researchers generally had to make up ad hoc workflows, sometimes building their own bits and pieces, but largely, relying on things like Google spreadsheets and stuff like that, which is, by the way, the same way that most journal workflows emerged in the day before there were any common tooling. So I want to talk a little bit about one example of this, Novel Coronavirus Research Compendium, NZRSE, who we've been working with. If you don't know them, essentially they're a community that looks at preprints, and they compile reviews of those preprints, community-based reviews, and they publish, reviews just to say, what their take is on these particular preprints. And it's to help researchers, navigate this field, this complicated, dense field, which has been, rapidly populated by enormous amount of preprints. So we were asked to work with them via eLife. I don't know if you all know eLife, the journal. Essentially, they wanted to help them, help NZRSE with their tooling, because their tooling was sort of like stuck together a little bit with gum and sellotape. And we've worked with eLife for a very long time. And we've built a platform called Kotahi. And Kotahi is an open source platform, and it's essentially a preprint micropublication and journal platform. And I'll talk a little bit why I think that the distinctions between these kind of platforms in the past has been arbitrary. Each of these kind of categories have had their own custom tooling. But actually, when you get close up to these things, they all look the same. There's no need to differentiate between these. And just to talk a little bit about Kotahi very quickly, and a typical journal workflow would look something like this. It's quite complicated. Author submits the content. It gets triaged by the editors. There's a cascading levels of permissions from editors. They hand the sort of paper down through senior editors, handling editors, etc. Then it goes through a review process. There's a lot of reviewer chasing, revisions are made, and then that goes through a cycle to a point where it's considered fit to publish, and then the publication goes to, the manuscript goes to production, and production prepares it for sharing with the public. And this is, a very slow workflow generally. There's a lot of sticky points. Reviewer chasing is one of the big ones, and the conversion of content to shareable content formats has actually been surprisingly slow and costly. The NZRSE workflow is quite different to the typical journal workflow, and I'm showing you these two because they coexist within the same system, Kotahi, and I'll talk a little bit about how that's possible. But essentially, they collate a lot of materials from various preprint servers in a Google Doc. They then in the past have been sort of with their own tooling sort of been managing this to look at it and sort of leave comments and stuff. But now they use Kotahi, and essentially we ingest from, instead of ingesting an article, we ingest all the line items from the preprints spreadsheet that they have. And then we populate each of those lines as a separate submission. So rather than submitting a document, the documents already exist out there in the preprint universe. We populate the system, and then the community looks at all of the preprints together in this one sort of holding bucket. They categorize those as community, and then each of those categories, so subtopics or taxonomy, are then managed by subsets of that community, and they write their reviews. And then they share their reviews. Those reviews are published on that site that you just seen, and all of that comes through and out from Kotahi. Also, we register the DOIs with cross-refer, etc. Now, the question is, how is it possible that we can actually coordinate these humans to do this this work quickly in a platform which also supports journals, and journals have, legacy thinking has it that journals workflows are very slow, yet we're talking about rapid processing within the same platform. So just covering very briefly some of the design principles of Kotahi. One thing that's very important is to realize that when you're designing systems for curation review, basically they all look the same from a certain point of view. They all have a create, review, publish, curate mechanism, but they might be in a different order or have a different priority. So typically journal processes have been create, review, publish, curate, create, review, curate, publish, but the preprints communities obviously want publish, review, or create, publish, review, curate. So, you don't have to design completely different systems. You just have to design enough abstraction and follow a few other rules in order to understand, or in order to contain these two types of processes within the same system. Another important thing just to talk about is to design with the users. We always design with all the users that will use the system, including, in this case, researchers. Another important design facet is to think about spaces, not functions. By this, I mean, if you think about workflow, when you're coordinating humans as a kind of conveyor belt, then you're making a very prescriptive, one-directional system that's very hard to sort of cope for the loops and eddies that often happen for ad hoc reasons when processing documents. Processing documents is a human function. It's largely not a machine function. And you need a system that is flexible, that can cope with people doing things at different times, often not in the same sequence as they are supposed to. So the idea is really to think about designing systems that have spaces. If you think about it as a house, if you want to at any time, go into the lounge, you should be able to go into the lounge. If you want to go into the spare room, you should be able to do that. If you want to go and do something in the office, you should be able to do that at any time. And so the point being is that you cross into these functional spaces to execute certain tasks. And system design, in my opinion, for publishing or sharing of research should follow these principles rather than a sort of conveyor belt principle. And that sort of brings me to the next point: to avoid workflow prescriptiveness. The processing of documents always has ad hoc moments, and so you have to actually design for that rather than try and pretend that they don't exist. And so the way to do that is not to enforce workflow prescriptiveness via the code, but to allow cultural elements to determine the workflow and provide these spaces so that people at the right moment can go into the right space and do what they need to do. Avoid multiple roles. Often we find within these kind of systems, you have 50 different roles for people, but they're all basically the same. They're just called different things. And it's a good thing to disambiguate roles that actually have a functional difference from those that are just and require some sort of extra permissions to those that just have a name that people know what to do. They do some stuff differently, but they might do those things in the same spaces as the other users with different role types. So avoid multiple roles when one will do. A single source system, sharing the same sources. This is not so applicable to preprints. Those sources are out there in the universe, not ingested into the system, but it's important to make sure that through all parts of the production, you are all looking at exactly the same source. A one-to-one design system basically means you only add functions to spaces and add a new space only when the coherency of that space is lost. In other words, try and make as minimal spaces as possible, these functional spaces, and then once you feel the system breaks that sort of concept for that space, then consider creating a new space. So in other words, you walk into a space where you can do a lot of different things, but you'll only do some of them, and we trust the user to make sure they know what to do and do it appropriately, rather than try and enforce that by the machine, so to speak. Features always abstractions. This is always an important thing to keep in mind when designing any kind of system, and especially this kind of system when you're talking about coordinating humans. You need to think about making just about everything an abstraction so that it can be used in a way you hadn't considered for another type of workflow. And of course, real-time communications, presence indicators, those sort of things in this day and age, especially when working remotely, are critically important. But it's important to note these things because in typical journal workflows, these things don't exist. So we built Kotahi around these principles. And with that, we're able to support both preprint and micropublications, also journal workflows. And it's a very, very flexible system. And I just want to talk very briefly, running out of time, is that the sort of new popularity of the preprints, I think, which has been stimulated by the COVID research that's been released early, has really made a lot of journals rethink what they're doing. And rather than preprints sort of being a hack, I think journals are now seeing that they need to share materials quicker. And then there are some moves to go towards public review, sort of curate model. where they sort of hybridized what is legacy preprint with legacy journal workflows. And eLife and their Project Society is actually a very interesting example of this, where they make sure that all submissions are actually preprints. There are community reviews around that. They also then ingest the document into their own review process, and they combine both kinds of reviews and revision cycles. And so they get the best of both worlds. They get the sharing of research early, and then they also get the process, which is valuable for peer review. We all know that it's flawed, but it also can be, if done well, it can actually, really improve the sharing of research, which is, of course, very important. Anyway, so that's basically it. It's a very short very short presentation, not quite the same kind of workflows we've been talking about so far, but touch on researchers and the researchers sharing their time-sensitive research early. Now, I think I'm going to go and try and go to the discussion.
Ngā mihi
Now I
nui,
can see
Adam.
the chat if there are any questions. I can't
We
hear
are, Adam can't hear any of us, so hopefully we'll try
I'll look at the live
putting
Q&A.
any questions you have in the Q&A. In the meantime, I'm going to try asking him a question around what does he see as the biggest challenges for open scholarly publishing, and what can we do to change that?
I'm seeing the chat now. Is that right? Sorry, I don't know if I'm interrupting you or not, Yvette. Shall I just go to these questions? What do you see as the biggest challenge for open scholarly publishing, and how do we change that? That's from you, Yvette. Yeah. So basically getting out of legacy publishing processes and systems. It's amazing how slow the sharing of research can be because of journal processes, and I think that's the first step, is making flexible modern systems, and the next step is then working out how to get away from the manuscript. All these things are in play at the moment, but the manuscript is a very sort of it's in deficit when it comes to sharing of information.
Identifiers, and also the role of publishing data and artifacts. Just let me type that in.
I see you typing. What are your views on persistent identifiers in the space and the role of publishing data and artifacts? Well, it's a big topic. Yeah, I mean, there's one layer of persistent identifiers which has a utility of just, an obvious utility, but I think where the real value comes is in the interlinking of all these systems. And I don't think that the persistent identifier conversation often gets to that level. I think we sort of talk about, ORCID IDs, or we talk about the DOIs, etc. But actually, the real value is when there's a multiplier value when all of these systems start understanding each other, and we're a long way from that. But they're very important. Thank you.
Thank you, Adam. We're going to move to our final lightning talk of the session, which is our speaker for the session is Jian Liu, food research, and he'll be talking on agricultural production simulators, next generation models. So the title is Automated Workflows Aids Biophysical Model Development, Couple R Targets and APSIMX.
So, hello everyone, thanks for coming today. I'd like to share something I did in the last year, building workflows to help developing biophysical models. In this particular case is APSIMX. I will introduce what is APSIMX shortly. Here it is. So it's an agricultural system simulator next generation. Basically, it's a workflow. It's a framework for simulating agricultural system. So it has climate components, plants components, soil components, as well as management. And the users then can build a virtual farm system, so we can investigate the interactions between the plants and the environments. For example, how much fertilizer we should put in to maximize the yield, but also reduce the environmental impacts, natural leaching and such issues. So, and the one issue I came across with when we develop those APSIMX plant models, there are lots of data we need. It's not necessarily big data sets. It's quite often it's small data sets, but coming from multiple sources and multiple locations. And ad hoc solutions is just, I don't see it's a solution at all. And it's very dangerous. Like we might done some analysis last year and then throw it away, or just can't remember when how did we arrive at specific parameter values during the analysis. So, and then there's another challenge is there are so many parameters in one APSIMX framework. So there are climate, plant, soil, we all need to look after them. This is the oversimplified flowchart, just a APSIMX flowchart about those parameters in charge of the mechanism inside the model. So the parameters I need to deal with is in the right box. And those are some of them can derive or calibrate from measurements, and some of them can't really be measured. So we have to either use some expert guess or use optimization process to estimate the parameters. And this is another simplified workflow, like how I use the optimization algorithm to estimate the parameters. For example, I have this single simulation as an initialized simulation, then go through the workflow to calculate the initial cost. And then based on that, the parameter, the optimization algorithm will jump to different parameter combination values and then select and then regenerate the simulations and do many times. One thing I'd like to keep is those intermediate results that the optimization algorithm has been tried, so I can come back and investigate which one give me the best and what are the parameter space has been explored. And that's some requirements I need. And because I use R quite heavily, so the targets package become a natural solution. And it was called Drake, but now it's called Target. So this next thing is about the flowchart, so I can figure out the dependencies and then to figure out what are the dependency in the data, in the function, or in the model. So here is a small example, like that node is not necessary in this workflow because it hasn't been used in the next stage, so I can get rid of it. Another thing about the targets is it's really nice to have that reproducibility, especially coupling with the RENV package. So I can basically reproduce this pipeline in any machine across system as well. And another benefit is the caching. So the caching has the targets package provide lots of caching capability and different formats. It means I can easily share the intermediate results with my colleagues or with my friends if they want to have a look. So some quick results. This is the runtime for about 3,000 simulations I did for estimate 9 parameters. Roughly, you can see 1,000 simulations cost 150 hours. If I reduce 1,000 iterations. If I reduce the iterations down to 500, the time is significantly reduced. And I just think this might be a good tool for me in the future to do some budgeting, to help me do the budgeting, so I can know if I have 9 parameters and 1,000 iterations, I can just say, oh, this cost maybe 300 hours plus a little bit designing the workflow. And also the flowchart helped me to do the profiling and to reduce the time cost. And I guess to help me make better functions. And thank you very much. That's all I have today.
Namahi nui, Jian. That was really interesting. Has anyone got any questions they'd like to put in the Q&A? I thought the budgeting graph that you showed, reducing it down to 500, was really look at kind of what an optimal was in that space.
As ad hoc, I have to admit. So, like the 500 iterations is really because the parameter space I have, the convergence is already reached around 300 iterations. So I just said, oh, 500 iterations is probably enough for these 9 parameters. I don't really need to do 1,000. The 1,000 was the first time I want to try out, and that was the recommended iterations number.
So we have a question from Roland. Thanks for the talk, and hopefully we don't get suddenly chopped off in 50 seconds, but have you calculated for the budgeting for HPC on-prem versus cloud based on your numbers?
Short answer is no, because I don't have any budget to use cloud space. I did explore the NZRSE option, but the APSIMX itself, it can run on HPC, but it's tricky and it requires constant maintenance. And we have a container, Singularity container in PFR to run the Singularity container. But because I'm using a custom build version of APSIMX, I need constantly update. And there is a resource cost. Like I have to bother the HPC team to constantly update the Singularity. I just gradually quit for that option because I don't really have a big millions of simulations to run.
Great. Well, we're out of time now, so thank you to all our speakers for the workflow session, and thank you for all attending the session today. If you have any unanswered questions or other things you'd like to discuss, please reach out to the presenters in the meeting hub. Otherwise, we're going to have a 20-minute break, and we'll see you at 12:30 New Zealand time for our next presentation session with a theme of community and engagement.